Assalamu alaikum. I am Hamza from Mechatronics Department of Air University. So today we are going to design a robotic system, which is a line following robot. This is my project proposed by my instructors. So in this project, we are designing a line following robot. This robot follows a black color line. So this robot follows a black color line, starting from a point to its endpoint. But in this robotic system, we are given some restrictions like we cannot use Arduino or any other microcontroller in this project. We are asked to design this robotic system using combination logics. Now, further in combination logics, there are various ways to design this robotic system, like K-maps and rudimentary logics. First, we designed this robotic system using K-maps, but in K-maps, the circuit becomes very complex. This is our DLD project of lab and subject as well. And our instructors told us to design a circuit and making it as simple as possible. Using K-maps, the circuit becomes very complex as we are using many ICs, but using rudimentary logic, the circuit becomes very simple as there are only two mugs and a not IC that we are using. So using rudimentary logic, the circuit becomes very easy and simple. And I have designed this robotic system using rudimentary logic. Our instructor told us that before designing any circuit, we must draw a block diagram, its truth table, and then we have to simplify it through Boolean algebra and using different Boolean equations. And when we have a minimized Boolean equation, we have to implement it on PROTEUS and check its schematic to verify the truth table. This is the way to be on safe and like if there are any problems when we design the circuit in practical. So we before designing that we checked that circuit on PROTEUS. So there are various steps that include in the designing of the circuit. First step is to draw the truth table and verify its combinations. So first in the designing of this circuit, I have drawn the block diagram and after that I design the truth table which is as follows. So in this project, we are asked to design a robotic system using four sensors. So as we know that when there are four combinations, then the possible combinations of the truth table will become 16 as 2 to the raised power 4 is equal to 16. So there are 16 total combinations. So for first sensor, we have drawn the truth table as 0000, and we draw all of its combinations. Then for second sensor, third, and finally for the fourth sensor. Now let's come to rudimentary logic and for the outputs of the motors. So there are four sensors: sensor 1, sensor 2, sensor 3, sensor 4, motor 1, which is the left motor, and motor 2, which is the right motor. So when the fourth sensor, which is the top right sensor, gives us one logic, which means that it is on, then the left motor should be on. In practical, we know that when we have to take a right turn, then the left motor ons. So in the same way, I designed this truth table. So for the top right sensor, we have to take the right turn and the left motor on, and there is one in the left motor. Similarly, when the middle right sensor is on, then the left motor again ons, and when both right motors are on, the left motor is on. Now, when the left middle motor on, it means that we have to take the left turn So the right motor should be on at this time, and there is one at the output of the right motor. Similarly, when both right and left motor is on, then it becomes don't care condition. Like this condition is not possible on our arena. One middle and one top right motor is on. So we have zero at both the outputs. And when both the when both the middle sensors are on, then both right and left motors are on. This is the condition when the robot is following a straight line. Similarly, when both right motors and the middle left motor is on, then it is the dominancy condition in which the left motor is on as both right sensors are on. For most left motor, for most left sensor, the right motor gives the one output when it is on. Similarly, when most right and when most left sensor is on, then it is again the don't care condition and we have right zero in this table. And when most left and the right sensor is on, then it is again the don't care condition and we have written zero in this state. Now, when both left sensors, the most left and the middle left sensor is on, it means that we have to take the left turn and the right motor gets on. Similarly, when the both left motors are on and the right motor is on, sensor is on, it means that we have to take a left turn and it is the dominancy condition. So sensors are dominant and in this state, the right motor gets on. In the last condition, we have to ask that when all the four sensors are on, the robot should stop. So both the motors are off. So it was all about the truth table. In the designing of this robot, we are asked not to use the Arduino or microcontroller. We are asked to design this robot using four sensors. So these were the requirements of this project. Now come to rudimentary logic. We can see that in rudimentary logic, we have to compare the output with the last, or we can say that the rightmost input. So here the rightmost input or the last input is a sensor port. So we have to compare the outputs of the motor with this sensor port. So rudimentary logic is about the pairs. We have to make pairs with this input of sensor port using the outputs of the motor. So for left motor, by comparison with the sensor port, we come to know that for first pair 0, 1, it is S4. Yellow color represents S4. So for the next pair 0, 1, here is 1, 1, which is 1. Green color shows 1. For the next pair in sensor 4, we have 0, 1, but here we have 0, 0. So it means we have 0 at the output and blue color represents 0 as we can see that from here. Now, for the next pair, we have 0, 1, but here we have 1, 1, so it is 1 and represented by the green color. Now, again, there is 0, 1, and at the output, we have 0, 0, which is represented by the blue color. And for all the next pairs, there are 0 at the output, which are represented by the blue color. Now, by comparison with the right motor, there is 0, 1, and for the right motor, there are 0, 0 for the first pair. So we have 0 at the output. Again, there is 0, 1, and we have 0, 0, which is represented by blue color as proposed here. Then 0, 1, and we have 1, 0. It means that we have the invert of sensor 4. It is the complemented input of sensor 4. So we have S4 prime, which is represented by the pink color. For next pair 0, 1, we have 1, 0. It is again S4 complement represented by pink color. Then for 1 0 we have 0 1 again. As for prime 1 0 0 0. I'm talking about this pair 0 1. We have 0 0 which is represented by blue curve. It is 0 0 1 1 0 S for prime, and then 0 1 1 0 represented by S for prime. So it was all about the truth table and rudimentary logic. After drawing the truth table and using the rudimentary logic, we simplified the equations obtained from this truth table, and using that simplified equations, we draw the schematic of this project. So we draw the schematic of this line following robot, and with the help of this schematic, we tested all these possible 16 combinations. And when they are verified, we implemented this schematic on the breadboard. Before drawing any circuit on the PCB, our instructors ask us to implement the circuit on the breadboard so that we could avoid any of the possible issues. So after this truth table and rudimentary logic, we draw the schematic, which is shown as. So this is the schematic of the line following robot. In this, we are using a NOT IC 7404, two MUX ICs 74151 given here. Then we have cell connectors for the cells, motor driver L298, and this is H-bridge motor driver. So before coming to schematic, we have to first discuss the connections of these ICs motor driver. So let's discuss their connections. So these are the connections of the ICs that we are using, the motor driver that we are using. Let's come to these connections. We are using a NOT IC which is 7404. So there are total 14 pins of this IC. First pin is the input, and then second pin is the output. Again, third pin is the input, fourth pin is the output. And in the similar way, there are inputs and outputs. The important pins are 7 pin, which is the ground pin, and the 14 pin, which is the pin of VCC. Now, for the MUX ICs, we are using 74151 IC. On this IC, there are total 16 pins. The 8 pin represent the ground and the 16 pin represent the VCC. Then there are data inputs and the data outputs. So first 4 pins are the data inputs. Pin 5 and pin 6 are the outputs. Using these 2 pins, when we patch the circuit on the breadboard, we use these pins for the output, and we patched an LED using these pins, 5 and 6 pins, as the output of the 2 MUX ICs. Then the 16 pin is again the VCC pin, and 12, 13, 14, 15 are the data inputs, and there are data selections. 9, 10, and 11 are the data selections. And on the schematic, these are represented by A, B, and C. So after that, we have a motor driver. Let's come to its connections. These 2 connections are the connections for the motors, and there are 2 motors. So these 2 connections are the first motor, and these 2 connections are for the second motor. As you can see that here is the output A and here is the output B. Then we have 3 connections here. These are 12 volt. Then the middle one is for the ground, and the third one is for the 5-volt supply. We cannot directly supply 12-volt to our ICs. Before using any component, we must consider its data sheet. And on the data sheet of these ICs, there is a maximum of 5.5 or 5 voltage uh, plus 5 volt that we supply to these ICs. So that's why we cannot supply 12 volt, otherwise our ICs will be burned. So we are using 5 volt for our circuit, 12 volt for the 12 volt for the starting of the motor driver, but we are using 5 volt in our circuit. Then there are these four pins. These are for the outputs of the ICs, mux ICs. If we want to rotate our motor in clockwise direction, we are using one and third, and in anti-clockwise direction, we are using second and fourth pin for the output of the ICs. So these are the connections of the motor driver. Then we are using IR sensor. Its connection are, as we can see that the rightmost is the VCC, middle one is the ground pin, and the most left one is the output pin. So these are the connections of the components that we are using in our project. Now let's come to the schematic. So till now we have discussed how we designed this robotic system. First we designed the truth table. After that we simplified the truth table using Boolean algebra and different Boolean equations. And when we have a minimized simplified Boolean equation, using that equation we draw the schematic on Proteus, and then we discuss the connections of the components that we are using in this project and the requirements of the project as discussed earlier are to use the combination logic and to use 4 sensors in this project. We are not allowed to use Arduino and microcontroller. Now let's come to the data sheet of the components that we are using. For SAM4151 MUX IC, the minimum voltage that we can supply is 4.5 volt and maximum 5.5 volt. That's why when we are giving 12 volt to the motor driver, we are using 5 volt enable pin for the circuit. Otherwise, the IC will burn out. And for SAM404 IC, maximum voltage is 5.25 and minimum voltage is 4.75. For both the ICs, the normal voltage is 5 volt. So these are the data sheets. After that, let's come to the schematic. So this is a schematic of line forming robot that I have designed. You can see that this is the voltage terminals, the voltage that we are supplying to our circuit. This is represented by 0 for the ground, 1 for the first and second for the second terminal. Second terminal is connected to 0, which is ground. So one terminal supplies the positive voltage, second terminal supplies the negative voltage, that is ground. Then there are the sensors. First one represents positive, second one represents ground. First one positive means VCC, second one represents ground, and S1 is the output of the first sensor. Then S2 is the output of the second sensor, 0 for the ground, 1 for VCC, again 1 for VCC, 0 for ground, S3 for the third sensor's output. And for the fourth sensor, we have 1 for VCC, 0 for ground, this S4 for its output, and in some cases, as in our truth table, there is S4 prime. So we connected a NOT IC or NOT gate to S4, which gives S4 prime. Then for these two muxes, we have S4 for the first pin, one, sorry, one for the first pin, then S4 for the second pin, one for the third pin, which is VCC, and then again S4 for the fourth pin. Then these are the data inputs. As I have already discussed the connections of these ICs. Then for the 12 pin we have ground, 13 pin is also ground, 14 pin is connected to S4 output, and 15 pin is again ground. And 5 and 6 are the outputs. So fifth pin is connected to the output of the left motor. And ABC are the data connectors. These are also the data selectors. E for the enable. On the left side, there is fifth pin connected to the right motor. First pin to S4 prime, second to S4 prime. These are the inverted inputs of S4. Then third and fourth pin are connected to ground. 12 pin to S4 prime, 13 to VCC, 14 and 15 again to S4 prime. ABC are the data selection lines connected to S1, S2 and S3. These are the outputs from these sensors. And then again E4 enable, which is the 7th pin and is grounded. Then there is the motor driver. Here are the two motors, J3 and J4. And here we have in the middle there is the ground, then plus 12 volt and plus 5 volt. We are using 5 volt in our circuit, but we are giving 12 volt to motor driver. Then the output from the left mux is connected to the second, and the output from the right motor is connected to the fourth pin. So these are the connections, and then we have Arduino cells. So there are 10 Arduino cells connected with VCC S4, VCC S4 to the output of the left motor, then ground, and the outputs from the first three sensors S1, S2 and S3. Then we have this Arduino cell connected to S4 complement, ground. Then the fifth pin is connected to the output of the right motor, seventh to the ground, 8, 9 and 10 to the outputs from the first three sensors S1, S2 and S3. So this is the schematic of this line following robot. After designing the schematic of this line following robot, we implement the circuit on breadboard. Let me show you the breadboard implementation of this circuit. So this is the breadboard implementation of the schematic that we have designed on PROTEUS. These are the four sensors. Then we have in the middle the ground, VCC, and these are the outputs. Output of first sensor, output of second, output of third, and then output of fourth sensor. These are the mux ICs. I have already discussed their connections and how I connected the sensors and this whole circuit. So the way I connected the circuit on the PROTEUS, in the same way I paired this circuit on the breadboard. So let me show you the combinations that we obtained. So when the top right sensor is on, the left LED glows. And when the middle right sensor is on, again the left LED glows on. And when both are on, the left LED glows on. So for the next combinations, when the leftmost LED glows on or both the when the leftmost sensor is on or middle and the left sensors are on, the right LED glows on. You can see that. In this combination, when both the right middle and the rightmost sensor is on, with the leftmost sensor to be on, the left LED glows on. We have seen here. In this combination, when both the left LEDs sensors, that is the leftmost and the middle left sensor is on with the right sensor, rightmost or the middle right to be on, then it is the dominancy of leftmost sensors. So the right LED goes on. So this was all about the patching on breadboard and verification of the logics with the help of breadboard. Now let's come to PCB layout. So this is a PCB layout that we have designed. In this layout, we are using 7 jumpers, 1, 2, 3, 4, 5, 6, and 7. The simple circuit is that in which we are using minimum jumper wires because the jumper wires become a problem when we are soldering. We are doing soldering. So that's why we have used minimum as possible, the jumper wires. Let me tell you one thing. This is the group project. A single individual cannot perform all this burden of work. So there are 3 group members in my group, I, and there are 2 other members, Bagheera, Salim, and Dua Majid. So we have divided our work, but we, with mutual understandings, with mutual table talks, and we perform collective work. So collectively, we have done all this work. So this is the PCB layout. In the PCB layout, as we are designing one-sided PCB, there are 2 types of PCB board. One-sided PCB board and a two-sided PCB board. So in one-sided PCB board, there is just we can say that we have to implement the PCB layout on just one side of the copper board. So that's why we are using top copper in this case. Now, when we have to print the PDF of this PCB layout, we have to select output, export graphics, and then export PDF file. While exporting PDF file, we must select separate pages. In this way, all the pages with jumpers, without jumpers, all the pages would come in PDF layout, and then we have to select that page of the PDF in which we have come with jumpers and the whole circuit. So we after designing the PCB layout, we printed the PDF of this PCB layout, and then there comes further steps for the hardware, which I will define you. So after designing the PCB, there is a butter paper on which we have to print the PDF of this PCB with jumpers. So before printing, we have to before printing of this PDF, we have to remove this sheet from the butter paper, and then we have to rough this butter paper so that the print comes fine on this butter paper. So you can see from here that I have removed this sheet, and then I roughed this butter paper and printed the PDF of the PCB out on this butter paper. The next step is when there is the print on the butter paper, we have to attach this butter paper on the PCB board, and then we have to iron it. This is the second procedure, the second step for the hardware implementation, which I will show you. As you can see that I'm gonna attach this butter paper on the PCB board, and then I am using iron to patch the circuit and to shift the circuit from the butter paper onto the PCB board. So you can see from here. So in this way, the PCB design from the butter paper is shifted on the PCB board. So when the design is shifted on the PCB board, the next step is to make the path clear. We must consider that there should be no break in this PCB design. If there is any break, we have to make it proper using the permanent marker. Otherwise, the break is left, and the circuit will be short from there, and the circuit is not completed. You can say that the circuit is not completed from that point, and we will not, the circuit will not give us the desired results. So in this video, I'm using permanent marker to prominent these paths. So you can see that. Trio Stupendo is the name of our group. It is our team name. So you can see that I'm using permanent marker to prominent these paths. So when the design is prominent on the PCB board, the next step is the step of etching. In etching, we are using ferric chloride solution, and then we place the PCB board in that solution and distill that for almost 20 to 30 minutes, so that all the copper other than this path is removed from the PCB board, and we are left with this path that we have designed on the PCB. So we have to do continuous training. So when a PCB has been designed, I solder the components on the PCB and with the specific calibration of the IR sensors, sorry, with the calibration of IR sensors, I patched those sensors on the chassis kit. And here is the line following robot of PROTEUS to Pando. You can see that it is following the line. When there is right and the left motor ons and the robot takes the turn. So when all the sensors are on, the line following robot stop. So again, first we have tested it by using first point as a starting point and this point as the ending point. Now we have tested this robot using this point as a starting point. Previous video. When there is left turn, the right motor is on, and when all the sensors are on, the robot is stopped. So this was all about the line following robot. In this project, I have learned a lot. I learned how to do soldering, how to perform etching, how to design a PCB using jumpers. As due to Corona in the previous semester, we are unable to do these. So in this project, I have learned a lot, and I wish to do like these projects more in my future. So summarizing this project, in this project, first we designed the truth table using rudimentary logic. We simplified the truth table, and using that simplified equations, we draw its schematic. Using that schematic, we patch the circuit on the breadboard, and when we have attained the possible combinations, we designed its PCB of suitable size that we should patch on this chassis kit. So after designing that PCB, we performed etching. After etching, we soldered all these components, and after that, we patch all these components on the chassis kit, and our line following robot is ready. Alhamdulillah. So this was all about my project, and I thank to my group members. With their cooperation, I am able to do this project. Thank you. Allah Hafiz.